Welcome. So we're going to go through question 6 here, and this is a problem-solving question, so it's going to take us a bit of time and it's going to require a bit of thought, so don't expect it to come easy. I'm also going to go through a long way of answering this question, a very long way of doing it. At the very end, I'll show you the quick way of doing it, but I'm going to show you the long way just so you can conceptualize and visualize what's going on, because otherwise, if we just go straight into the quick way of doing it, you won't really understand what's going on. So the question says, let me get my highlighter. For the graphs of these rules, state the coordinates of the 2 points at which the line cuts the X and Y axis. That's what we want. We want the coordinates for which the line cuts the X and Y axis. Now, at first you're like, what exactly is this asking me? I'm not quite sure. Well, when you're not sure what to do what you can. Let's draw it. So let's draw the line y equals x plus 1. And remember, the way that you do this is we can first use our table of values to figure it out. So let's sub in first, when x is equal to 0, what would my y value be? So remember, the way that you do this is you sub in x is equal to 0, and that means you're going to get y is equal to, I put a 0 into my x spot, 0 plus 1 is 1. So I put a 1 here. And remember, this is a coordinate, isn't it? It's coordinates, so it's 0, 1. So I can come here now and say, well, 0, 1 is right there. Perfect. All right, let's keep on going now. So the next thing I would do is just continually sub in values to get lots of points, and then I can draw myself a line. So I could go x equals 1. Well, when I go sub in x equals 1, it's going to be y is equal to 1 plus 1, y is equal to 2. So it'll be a 2 here. So I would go 1, 2. And then we could keep on going. We could put 2 in next. When I sub 2 into this, I'm obviously going to get 3 out. So 2, 3. When I sub 3 in, well, 3 plus 1 is 4. So it's going to be 3, 4. And you could keep on going. You could go sub in 4 next. 4 plus 1 is 5. So it'll be 4, 5. Let's now go backwards. So let's now figure out what -1 would be. So if I sub x equals -1 into it, so that means into my x spot, I'm putting -1. I then am plussing 1 to it because that's what my rule tells me to do. What is -1 plus 1? Well, it's 0. So I'm going to put a 0 here. Let's put that here. So my x value is -1 and my y is 0. So that just means it stays right there. What about -2? Well, if I sub in x is equal to -2, I'm going to get y is equal to -2 plus 1. Y is going to be equal to -1. -1 here. So -2, -1. Right there, -2, -1. And then the last one would be -3, well, not the last one, but on my table of values, -1 plus 1 would be -2. But of course, this thing keeps on going, doesn't it? We've just done a whole bunch of points, and we can now draw a line through these. Now, did we need this many points to draw a line? The answer is, of course not. We could have just had 2 lines, 2 points, and then used our ruler to connect them up. But I've done more, and you'll see why I've done more soon. So let's now draw a line through this. And remember, this thing just keeps on going. It keeps on going. Because if I was to sub 6 in, I would get 7 out. And we can check if that works with my rule. 6 plus 1 is 7, so that checks out. What if I put 8 in? This is telling me that I get 9 out. Well, 8 plus 1 is 9, so it checks out. So I've drawn it correctly, and you didn't know that this line just keeps on going on and on. All right, but this is all just a stepping stone to get where we need to go. Let's get rid of this. Let's get rid of that. All right, let's now take a breath. We're now going to figure out where this line cuts the X and Y axes. So where does it cut the X and Y axes? So let's get some colors here. I know that this is my x-axis. What coordinate does the line cut the x-axis? This coordinate right here. This one right here. This is the point, what? -1, 0? And it's the point at which it cuts the x-axis. Now, I don't like the word cuts. And later on in maths, in your later years, you don't use the word cut. Rather, what you say is you use the word intercept. So you could say it intercepts the x-axis. So let's use that. Let's be a bit fancy. Let's say that this is the x-intercept. Oh, that's going to be a very important idea in your later maths education. So we have found the x-intercept. And all that means is it's where the line cuts the x-axis. But we've given it this fancy name now, because why not? So that is our x-intercept, -1, 0. And that's going to be one of our answers. So you can see how we've done this. We've drawn our graph, and we've found one of them. Our x-intercept is going to be -1, 0. I also need to find where it cuts the y-axis. And you can imagine what we're going to call this. We're going to call it the y-intercept. So here it is right there, this coordinate right there. What is that coordinate? That is the coordinate 0, 1. Let me do it a bit higher up. 0, 1. That is my y-intercept. It's my y-intercept. It's where it cuts the y-axis. Because this is my y-axis, and this is the point at which the line cuts it. It's touching it. It's intercepting it there. All right. Perfect. And they're your answers. So technically we're done. But I think you would agree with me. You know, it would take you literally forever to get through this exercise if you had to draw it out each time. So we need to figure out a quicker way of doing this to really help us out. Is there a quicker way of identifying the x and y intercept? And this is where we have to turn our thinking caps on. All right, let's look at table values. Okay, and let's look at our x and y intercept. So I know, let's come here. Let's come here. I know that -1, 0, so this point right here, this coordinate right here, this was my x-intercept. So it's -1, 0, and it's my x-intercept. I'm just going to write int, x-intercept. And then 0, 1, 0, 1, 0, whoa, 0, 1 was my y-intercept. All right, are you ready to do some thinking for me? Is there something special about these coordinates that none of the other coordinates have? So is there something special about this coordinate and this coordinate that none of the other coordinates have? What's special about them? What's different about them? What do they have? What did this coordinate and this coordinate have that none of the other coordinates have? Have a look. Pause the video. Have a good think about it. Because if you come up with the answer, you should be very proud of yourself. All right. Hopefully you got it. It's the fact that they have zeros. Do you see here, for my x-intercept occurs when my y is equal to 0. And my y-intercept occurs when my x is equal to 0. For every other coordinate here, there are no zeros at all. 1, 2, 2, 3, 3, 4, 5. You know, they're always, none of them are zeros. But for my x and y-intercept, one of those coordinates is going to be 0. And what we say is that when and this is true for every x-intercept, my x-intercept occurs always, occurs when my y is equal to 0. And my y-intercept always occurs when my x is equal to 0. Always. Always and forever. All right, so how can we use this information to help us out to answer this question? All right, let's come over here. And let's write this down. So let's first start with my y-intercept, shall we? And I want you to write this down. The y-intercept always occurs when x is equal to 0. The y-intercept always occurs when x is equal to 0. So to find the y-intercept, we're just going to say let x equal 0. So I'm going to take my rule. My rule is y equals x plus 1. I'm going to let x equal to 0. That means y equals 1. And that means when x equals 0, y equals 1, I get the point 0, 1. And that is my x-intercept. Just like that. This is the quicker way to do it. Do you see how quick that was? I didn't have to draw a graph. I didn't have to do a table of values. I knew that my y-intercept is always going to occur. I know that the y-intercept always occurs when x is equal to 0. So by letting x equal 0, I just found what my y is equal to, and I found my x-intercept. That should say y-intercept. Ugh, sorry. What am I doing? That should say y-intercept. Sorry about that. So to find the y-intercept that occurs when x equals 0, I always do that. So that is where it occurs. And you can see here, there it is. All right, next, let's do a little line of partition. What about the x-intercept? The x-intercept always occurs when y is equal to 0. And you can see that on our graph here. You can see it on our graph here. The x-intercept, our x-intercept, occurs when y is equal to 0. Always. Okay, so how can we do this then? Then to find it, we can just say, well, let y equal to 0. So remember, your rule is y equals x plus 1. I'm going to let y equals to 0. That's going to be x plus 1. And then what you'd actually have to do is find what my x is going to be. So we're going to have to actually do some rearranging. Do you see how math is all related? Remember when we learned about equations? That feels like a while ago, but we did it. So I'm going to minus 1 to both sides. And that tells me that x is equal to -1. And that makes sense as well. If x was equal to -1, -1 plus 1 is 0. But you can see how we did it there. So that means x is equal to -1. So that means when y is equal to 0, x is equal to -1. So I can write now, this would be my coordinate, because this is my x, this is my y, and this would be my x-intercept. So my x-intercept occurs when y is equal to 0, and just like that, we've done it. Let me grab this, just like this. So again, this is a challenging idea. It's the reason why it's in the problem-solving section, but it's a very important idea. So you don't, in the future, you don't actually have to draw a graph like this. You don't have to do a table of values. You can just say, hey, I know this very important fact, and that is that my y-intercept always occurs, well, the y-intercept always occurs when x is equal to 0. So you let x equal to 0, and you find out what it's going to be, and that's going to be your y-intercept. And then to find the x-intercept, you say, well, the x-intercept always occurs when y is equal to 0. So you let y equal to 0, you solve for x, and then this is going to be your answer. Hopefully that makes sense. A tricky idea, but an important idea. In the next example, I'm just going to go through this. So in the next part, part B, I'm just going to go through this section right here. And then after I've done this section, then I might backtrack and show you this way. But this way actually isn't necessary. You actually don't need to do this. This is just helping you to understand, but you technically don't have to do that. You could just say, hey, my y-intercept occurs when x is equal to 0. My x-intercept occurs when y is equal to 0. And then solve. All right, hopefully that made sense. A tricky idea. Make sure you reach out to me in class if you're having any problems with it. But I'll also go through 6B, so check that out as well. All right, I'll see you in the next one.